Alright students, this is page 93 of the notes. Now, in class and in lecture, I usually show the traditional method of hypothesis testing, also known as the critical value method. This was really the first method introduced to me as a student, and the most traditionally used method of hypothesis testing. It can be used with any kind of calculator and without a calculator, actually, as long as you're okay with doing a little bit of arithmetic by yourself. I will also show you how to do the p-value method by hand, and then I will show you how to do the p-value method using a more advanced tool such as a graphing calculator later. So look for those videos if you're interested. On this problem, it's an introductory problem to just a hypothesis test about a single mean. Okay, so we have a one sample situation here, and it says that a cigarette company claims that their cigarettes contain an average of 10 milligrams of tar. A random sample of 100 of their cigarettes show that the average tar content per cigarette is 11.5 milligrams with a standard deviation of 4.5 milligrams. Does this data indicate the average tar content of the company's cigarettes exceeds 10 milligrams? Use a 5% level of significance to perform a hypothesis test. Okay, if you're collecting information, you might want to go through and do that. What I'm going to do though, and what I do, the first thing that I do, is I just set up my hypothesis. Okay? So hypothesis. That is step one. We're always going to set up H0, the null hypothesis, and HA, the alternative hypothesis. This is a one sample, and it's going to be a z-test. Okay? We haven't talked about this yet, but we happen to know the population standard deviation. We're going to assume that in this scenario. Since we have a one sample test, it's about a mean, we're testing about the average, we're going to have mu's on both of these. H0 is always what they're claiming. So they were claiming that their cigarettes had an average tar content, right here, claims average of 10 milligrams. It's usually in the first sentence. And HA is what you're suspecting. So HA will be the question. It says, does the data indicate that the average tar content for the companies exceeds 10 milligrams? So exceeds implies a greater than symbol. Right? Once you get your hypothesis set up, you're going to locate what is called a critical value. And this is a one sample z-test where we assume we know the population standard deviation. And we also have a very large sample size. So that is another reason to go with a z-test. We're going to look up a z critical value with an alpha level, and it's going to be a one-tailed test because this arrow is an arrow. If it's a greater than symbol or a less than symbol, it's a one-tailed test. If it's a not equal to symbol, it's a two-tailed test. So we have a one-tailed test, and let's find our alpha, our level of significance. Up here in the paragraph, we can pick out that alpha is 5% because alpha is your level of significance. So alpha is 0.05. Okay? Now go to your z table that I gave you, or that is located in your book, and you can look up alpha levels various ways. What I like about the table that I use is it has a little cheat section down at the bottom. Remember before when we were doing confidence intervals we used the little cheat section. This is a little cheat section as well. All of these values, which I know you've encountered them before, up here, they can be found up here, but it's nice just to look at them in this cheat table. This table's kind of dark, but It says hypothesis testing, critical value. Sorry, I'm digging because I think I can find you a better table, and I did. I want my original table because it's easier for you to read. Okay, sorry, I had to fold it. There we go. My green table. Hypothesis testing critical values. Okay, Z naught. Critical value for a left-tailed test, critical value for the right-tailed test, critical value for a two-tailed test. We have a one-tailed test. The arrow is pointing to the right, so it's going to be a right-tailed test because the arrow was pointing to the right. So when we look up on our little cheat table, we're going to look a critical value for a right-tailed test. We're going to use one of these. These are the most common alpha values used, 0.05 and 0.01. We were using 0.05 in this problem, so let's write down the corresponding Z critical value. Alright, once you've done that, you shade or set up your picture, your rejection region. So you plot the critical value, which is 1.645, and you shade the tail. You shade in the direction this arrow is pointing. This arrow is pointing right, so you shade to the right of your critical value. And this is your rejection region, which I will often abbreviate RR. Now, after you do that, you go to step 3, which is to calculate your test statistic. If you're using a z-test statistic, for a one sample, it is z equals x bar minus mu divided by sigma divided by the square root of n. Now you have to find x bar, the sample average. If you read above, the sample average was 11.5 milligrams. Mu is what they claimed it to be right here in step 1, 10 milligrams. Sigma was the standard deviation that they told you, 4.5, divided by the square root of n, their sample size, which was 100. Now you want to make sure that you do the numerator and the denominator separately, or that you tell your calculator to do them separately. When you calculate this, you should get a test statistic of 3.33. Now, you want to plot your test statistic on your picture that you drew. Where does 3.33 fall on this number line? Does it fall to the left of 0? Well, it's a positive value, so no. It falls to the right of 0. Is 3.33 bigger than 1.645? Yes, it is. Your test statistic is going to fall somewhere in here, which is in the rejection region. If your test statistic falls in the rejection region, your decision is to reject H0. Since the test statistic fell in the rejection region, you will reject H0. Okay? If it does not, then you do not reject H0. It's as simple as that. Once you've made your decision, you're ready to go to your conclusion. I've set up a very generic conclusion. It's sort of cookie cutter. You can use it in any problem that's a one sample hypothesis test about the mean. You simply say, based on the evidence, the average, and then you talk about what kind of average they were talking about. They were talking about tar content. Is or isn't significantly. If you rejected, then you select is significantly. Okay? Rejecting H0 means it is significant. Significantly. What were we trying to find out? We were trying to find out if it was exceeding 10 milligrams or if it was greater than 10 milligrams. Whatever this symbol up here is saying, that's what's going to go right here in this place. We're going to put a greater than word to match that greater than symbol. Then the next blank space is what they were claiming, 10 milligrams. The alpha blank space is the level of significance we were told to use, 0.05. So what we found out, we were testing to see, does the tar content equal 10 milligrams or is it greater than 10 milligrams? After a hypothesis test using critical value method, we found based on the evidence the average tar content is significantly greater than 10 milligrams at an alpha level of 0.05. And you're done. That's a 5-step method to do the traditional critical value method of hypothesis testing, one sample means.